Once again, ladies and gentlemen, I am pleased to welcome you to today's Msdn webcast entitled Visual C# Soup to Nuts, Part 21, C# and Game Development. And once again, I would like to introduce today's presenter, William Steele. Bill, you now have the floor.
Thank you, Michael. Welcome back, everybody, to this C# Soup to Nuts webcast series. This is Part 21 of our 22-part series, and we will be talking about game development today. So, shall we begin? We're going to cover a few things. First off, we're going to be talking about game development on C#, and Microsoft has released just recently a SDK that allows for game development on within C#, and we call that the XNA framework, basically. And we have a new version, just like we have a version of C# for developing web applications. We have a version of C# for developing games that we call Microsoft XNA Game Studio Express. So we'll be talking about that. We're also going to be taking a look at one of the ways that you can start game development with C#, and that's through the use of starter kits. Okay, we've got a couple different types of starter kits we're going to be looking at. The first one is the type of starter kit that's actually included with XNA Game Studio Express. And then the second type of starter kit is the type of starter kit that we would use as a standalone within C#, where all of the code doesn't rely on the XNA framework, but instead is purely a C#-based game. And we'll discuss the differences and the benefits of each one of those. And then lastly, we'll go ahead and we'll start up a very, very simple game. I'll show you some of the basics using the XNA framework and build a really quick little example application that can be sometimes called a game, if you will. But hopefully it'll give you a better understanding of what's going on inside there. So to start off with, I do want to talk about the XNA framework, which is a framework for game developers built on top of, or built as a subset, if you will, of the .NET framework. And I do want to point out that there are actually two different versions of this framework, specifically targeting the platform that you're going to be writing the games for. One of the nice things about XNA is it allows you to build not only Windows-based games, but also Xbox 360-based games, which is a real benefit. We can have one code base targeting both platforms with this framework. When we run XNA games on our platform, on Windows we're using the full version of the .NET framework, and then the XNA is built on top of that. When we're running on Xbox 360, we actually have a version of the compact .NET framework that runs on the 360. Some of the things to talk about when we're building these games is that we do have some special features that are designed explicitly for game development. For example, we have the way we actually model the game itself, or the actual software itself. We have a specific structure that's designed explicitly to be handled by games. When you think about writing an application, the workflow for writing a game application is entirely different than the workflow for writing a program like Microsoft Excel or something like that. So we have to think about it from an entirely different view. And what's interesting about it is that we find that most games follow the same kinds of rules or the basic structures. So what we've done with the starter kits and with the Visual Studio environment is we've actually built a framework that takes care of most of the common types of things that you would do with a game. And one of those things is the ability to handle media and graphical elements and audio and things like that. And we do that in XNA framework through something called the content pipeline. The content pipeline is a feature that allows us to simply load in the elements that we'd like as items in a subdirectory structure. And then once those elements are in there, then we can simply refer to them using a basic load mechanism that we can load those items into an object and then call the methods on that object. XNA is very graphical in nature. We do have the ability to do some very advanced graphical functionality. It's all based on Direct3D and DirectX 9, which has been ported, by the way, to the Xbox 360 as well, so that we have some commonality between the platforms, especially when it comes to dealing with these different types of objects. Now, at this point, C# is the only language that's supported. I know that they are looking at supporting other languages. We've been asked about it, and I don't know the difficulty in doing that, but I do know at this point that C#, as a matter of fact, C# Express is the only supported developer platform, and C# is the only language. But I'm sure that the C# Express limitation is going to be going away in the next build or two, because that's one of the biggest requests, that we also support Visual Studio. So speaking of Visual Studio, we have a customized version of the Visual Studio environment for developing games called Microsoft XNA Game Studio Express. And basically what this is again, it's a free version of Visual C# Express. Basically, you install C# Express, and then you install the XNA toolkit on top of that. And that adds a whole bunch of game developer tools to Visual Studio. Some of the things that it adds are, for example, the ability to build and debug the applications. And we do this just like we would do in a normal application. So the debugging mechanisms, the tracing mechanisms, the ability to run and debug and step into the code and view the objects is completely supported within this. But what's interesting about this is that it's been expanded way beyond the machine that we're running on. So for example, if you're building an Xbox 360 application and you need to debug it, you can actually debug it on the 360 simply by connecting to it, running from C# Express or XNA Game Studio Express. And you're running it from that environment, but the actual execution is occurring on the Xbox 360. And you can hit breakpoints and examine the variables and things like you would normally do as you're debugging. But the code is actually running over the wire on the Xbox 360, and that's a real benefit for debugging, an application and trying to figure out what's going on. We do have at this point 2 different project types. When we're building games, we have one for building Xbox 360s, and we also have another project type for building Windows games. Now, the code I said is you can share between the two. The reason we have 2 different project types, though, is because we have some differences in the platform, the way the communications are set up, and things like that. It doesn't really have anything to do with your code, but it's more about the environment that it's going to be running in. And then project type helps us define those settings. I do know they're working on coming up with a common project type that would support both of them as well. But literally, if you wanted to, you could literally just copy the code from one of the projects into the other project, and it would run just fine. Now this brings us to this concept of once we have it in XNA Game Studio Express, what can we do with that? Well, to begin with, we actually have starter kits to build, to learn about building games. And the first one that's been shipped with XNA is the Space War Starter Kit. And the Space War Starter Kit is a starter kit that it includes all of the source code. So when I launch Game Studio Express and I create a new project, one of the project types is going to be one of these Space War Starter Kits. I can choose that Space War Starter Kit and go ahead and run it immediately, and I'll have a full Xbox 360 or Windows-based game, depending on which one I start. By doing this, I can, we're hopefully providing you with a really nice sample application that you can go through and dissect and modify and do whatever you want to with to learn more details about how game development actually occurs. Now, these starter kits are specific to the XNA platform. However, we also have starter kits, which I'm going to be showing you, which are not specific to XNA, and in fact are not targeted to Xbox 360. These are just Windows-only games, and Visual C# Express actually has the ability to add on, if you will, these starter kits on its own. So I'll show you a couple of those once we move into that portion of the demo as well. Now, these starter kits are not XNA-based, but all of this code is there. They're C#. It's purely a Windows-based application, and you can learn quite a bit about game development from there. And what's interesting is if you take a look at the code that's in there, in the starter kits that for C# as well as the starter kits for XNA, you'll see that there are a lot of commonalities between them. For example, they're going to have some basic things like an update method, which is going to be Basically, it is your game counter, your game engine itself. That's where the logic of the game is going to occur. And there's also going to be some form of a method where we actually update the screen. In XNA, we call that the draw method. And really, those are the two primary methods that any game is going to have: the ability to update the logic of the game and the ability to update the display of the game through the draw method. So let's go ahead and pop into a quick demo here. Actually, maybe it won't be so quick, but we've got quite a few things to demonstrate in this demo. We're going to start off by taking a look at some websites where you can get more information. And then we'll launch Csharp, and we'll show you some of the various different types of starter kits that you can play around with when you're learning game development. So when I move to the next slide, my computer is set to 1024 by 768. So you're going to see if your machine is set to that resolution or higher, you can press the F5 key to see my entire screen, which is going to help you getting the full view here. And I see there's a question in the queue already. Andre is asking, can XNA Express version be installed on the same machine with Csharp Express without problems? As a matter of fact, it does require that it's installed on the same machine. So XNA Express does not stand alone on itself. It actually installs in there. Okay, so let's go ahead and move to the next slide here. And the first thing that I want to show you is my Csharp Soup to Nuts. Actually, this is my blog here, and you can see the very latest entry is on this session, the game development session. And down here, as always, I have my demo code attached. Here's my blog address up here at the top. It's blogs.msdn.com/wsteele, and that's all you need. And that'll you can go right there and download the sample code here. Now, the sample code that you see here is actually going to be the last demo of the day. Everything else that you're all the other sample code that I'll be showing you today is going to be available from websites, which you're going to be seeing in just a second. So the first place I want to take you when we're talking about game development in Express is the Microsoft Visual Studio Express site. And we actually have a site specifically off of that for game development. So vstudio/express/game will take you right to our game development site. Now, we've done a lot of things out here. There's quite a bit of information out here on actually building games. Let's just go through a few of them. First off, you see right here we have projects that you can build. And these projects here actually represent 3 different starter kits. Actually 2 starter kits and 1 full game that you can actually download and start learning about. The Blackjack starter kit is based off of the card game starter kit, and then Space Blitz is another one of them. It's very similar to the some very ancient games, if you will. And then the last one is a Rocket Commander, is a game that actually includes a whole series of tutorials on actually building game development. And when you're done going through that tutorial, you'll learn a lot about building 3-dimensional games. And I believe there's 10 hours of videos just in this one session alone. So this is highly worth it if you want to, start learning about building 3-dimensional games like this. Now, what's interesting about this is all 3 of these types of games can also be built on top of XNA. This style of game, and these are pretty much the classic games that you would have a game. A card-based game or some type of a puzzle or something like that, a 2-dimensional game, and a 3-dimensional game. Below down here we start introducing XNA Game Studio Express, and basically XNA Game Studio Express is a way you can again build games for both Windows as well as Xbox 360. And if you click on this link, that'll take you over to the Game Studio Express site, where you can actually explore the team's blogs, some of the development forums that are out there. And there's quite a bit of information out about building XNA itself, and we're going to be doing most of our demos today in that. But I do want to talk about some of the other features here. For example, we're going to go ahead and build and show a couple of these starter kits as well. But one of the items that you'll probably want to definitely check out, because I only have an hour or so in this webcast, this site right here really is your doorway to learning a whole bunch more. And there's a link specifically right here called Beginning Game Development. We'll take you step by step through some tutorials on how to do that. And here you can see I've brought that up. You can see that there are quite a few series out there, talking about the different aspects of game development. When we talk about game development, we also have to talk about things like DirectX and how we get input from our joysticks and how we do sound and things like that. And this Coding for Fun site actually contains a lot of information on how to do that. So I highly recommend you go out to there. All of these links, by the way, are off of Microsoft.com/vstudio. And then if you just click on Express and Games, you see that all of that information is off of that. Now, I do want to point out today that as I go through these game developers, I'm actually using the Xbox 360 for Windows controller. This is specific to Windows. It isn't your standard Xbox controller because it actually contains drivers that actually work with Windows XP and Windows Vista as well. It has a standard USB connector. And I've got that plugged into my computer. Now I see down here there's a new version of this. I'm not real sure if this one would work or not, but there is another version of this that has a wireless connections. Now I've always recommended the wired connectors. I haven't tried the new Xbox 360 controller for Windows Wireless Edition. I have not tried that yet, so I cannot confirm if that works or not. I do know that the wired version works. And these you can get for around $35 to $40 in any standard store. But this is the exact controller that I have hooked up to my my computer as we do these demos today. Okay, so let's pop over to C#. And let's go ahead and create a new project here. And the project that we're going to create is going to be a starter kit. Now you'll notice that when I bring this up that I have several starter kits installed here. Here we have Space Wars for Windows and Space Wars for Xbox 360. I also have the card game starter kit and the Space Blitz starter kit. These are under templates. These other two are under actually Visual Studio installed templates. And the difference between them is that these do not rely on XNA. These do rely on XNA. So let's go ahead and create one. Let's go ahead and create the card game that doesn't rely on XNA. And by the way, as I create these templates, these projects from these templates today, these are not in my demo code because this is standard downloads, and I won't be modifying any of this code from the standard download that you can get from the game site. Now you see that when I create the starter kit for this card game, it's given me a really nice README file that introduces me to this game and how we can walk through it and look at the source code and learn from the source code. And you'll see that all of these starter kits actually do this, where we can see the classes that we're dealing with and what that actual class is used for. Not only can you do it that way, but you can also look through the actual projects themselves. And for example, see the start form or the actual game objects themselves. Here's the deck and here's the cards. But if I just go ahead and run this, you'll see that it's just going to bring up the blackjack game. And by the way, any of these games that you see me running today, they look much better on the local machine than they do over live meeting. For example, this green area that you see right in here, there's actually a bitmap image there that has a couple faces in it of people playing cards and things like that. So the resolution, and there's a lot of information lost when we go over the wire for the live meeting, but hopefully you get the idea of how this works. If I go ahead and create a new game, you'll see that I've got a character playing that has her name is Karen, and this is the default. We start out with $4,000 in our bank, and I can go ahead and bet $25 and take a hit playing blackjack here. Actually, we'll deal that. So I've got 14. I can take a hit. 15. Ooh, that's a tough one. Let's see. We'll stand on that and see if the dealer busts. And the dealer did bust, so I won that game. So that's a standard a little game that you can play, and there's quite a bit that you can do with this. For example, here's a list box that has images that they've loaded into it, so you can select your different images and you can change your name. And then when we go back and play the game, there I have my new information. And this is a standard game. There's nothing fancy. I've not added any code to this. This is the way the starter kit works. Show you the second one. we'll just go ahead and discard those changes and bring up the second one, the Space War. I'm sorry, the Space Blitz game. You've probably seen a game very similar to this, or probably played a game very similar to this in the past. In this case, when I just press any key, I can move the arrow keys left and right and press the space bar, and that fires. So we have a very, very familiar game experience here. And this is the classic 2D style game that we can play. And again, just like the others, all of the source code is included in here. So here we see our game state, we see our game object itself. The actual program itself, this is the main entry point to the program. And there's a class called Space Blitz, and this happens to be the form that the game is actually played on. And inside there we can probably view a whole bunch of the code that's going on inside there and see how this Space Blitz game actually works. So that's this by the way has a really nice document here on how this game works and what all kinds of details are in it. They include quite a bit of sample code. So if you're looking to build just a Windows-only game, this is a fantastic starting point. It introduces you to the concept of what a sprite is, and how do you detect pixels when they collide with something else. We call that collision detection and things like that. So there's a bunch of information just in these starter kits, without XNA that you can learn from. So let's go ahead and create another one. Only this time I'm just going to create a new project based off of the Space Wars starter kit. Now, the Space Wars for Windows and the Space Wars for Xbox 360 produce the exact same game, but they just have different targets. One is going to run on Windows only, the other one's going to run on the Xbox 360 only. So we'll just go ahead and create Space Wars starter kit there. And this will take a few minutes to spin up. Now, what's interesting about this is it is going to be relying on the XNA framework. So we're going to see a lot of differences inside the way this game actually works. For example, when we're running Space Wars, we have this Space War game class, and by default, all XNA-based games derive from a parent class called the XNA Framework Game. So this is the namespace Microsoft.xna.framework, and the class is called Game. And Game has two basic methods that we're going to be dealing with. The first method, as I said earlier, is going to be the draw method, or the update method. And here's the update method. And this is the method that we would use to actually update our game logic. So, if I'm having to maintain the position of characters, or if I'm having to maintain the position of a bullet that I fired, or some objects out there. Now, that's all going to be done inside this update method. In addition to that, we're also going to be looking at things like the state of the game controllers, which buttons are pressed and which keys are pressed on the keyboard and what's the mouse position, things like that. Those are things that we're going to be handling inside the update method as well. In addition to the update method, we have the draw method. And the draw method is the method that we're going to be using to update the display of the game. And in this case, you can see that they have a class specific to the game called current screen, and they have a method called render that's simply going to draw that. And this is a good way of handling it. It's very important to understand that when you're building games for either the Xbox 360 or Windows in general, that when you build a game, you make the drawing routines and you make the game logic as light and performant as possible. The more, the lighter you make the game, the less CPU intensive on every turn, the game is going to perform a lot better. So let me just go ahead and launch this. And this is going to launch this. They've done some really interesting things inside the Space War starter kit that I really like. They have a once I build this will take just a few seconds to build. But once it does build, you're going to see that it creates two different versions of the game. They've actually built two different versions of this. So in one shot, you can learn about doing two-dimensional games as well as three-dimensional games. And done a really nice job of incorporating both sets of functionality in one game. Now, Space War is a game that was written a good 40 years, maybe even more ago. It was the first video game, not the first public video game like Pong or something like that, but this was the first video game for a computer. And it was originally designed on some very crude PDP-1 computers and PDP, later on the 11s and such. That's the whole series. But what it was a game that was, designed to show the power of the computer, if you will. And obviously some guys were just playing around when they did it. Let me go ahead and drag this to the screen so we can see the whole thing. I'll take a second to update the display there. There we go. So this is the main menu, and you can see it actually has the Xbox 360 style buttons on it. So we have the X, the A, and the B buttons, and those are standard buttons on the 360 controller. But I can also use my keyboard to do some of this function. So if I, for example, go ahead and hit the key there, this will take me to the setup for the current version of the game, or this is the modern version. And you can see that there's actually two spaceships there rotating around. They might be a little distorted in your display. But that's simply because of the updating. In addition to that, we also see that there is some ghosting around the actual top left spaceship. And as I change that, I can actually move that down, and that'll move to the middle spaceship and the bottom spaceship. Now you have to take my word on it. This looks so much better on the real machine than it does over the wire here. I highly recommend you go out and download and play that. And see the difference for yourself. The graphics quality, the anti-aliasing of the images, things like that, just does not exist when we push it over the wire like that. But now that I've done that, I can also change the colors of my ship. And you can see as I make the changes to it, my ship that I've selected there actually changes. So there's an orange, and I kind of like that spaceship right there. And then I can go ahead and hit A to select that, and we can start playing the game here. But I like to go back and show you the retro version, because this one actually works pretty good too. This is the original version of the game, and what they've done is they've actually included all of this code in there as well. So basically in Space Wars you have two ships opposing each other with the sun in the middle, and you can shoot at the other ship similar to the way you would shoot at an asteroid in Asteroids. Or you can just let the other ship run into the sun that's in the center of the screen. And you can see there's this basic gravity effect. So there is a very simple physics engine that is drawing everything towards that sun in the center of the screen. And if you download and play this game, you'll see something pretty interesting. Your bullets actually curve around the sun as well. And I'll see if I can get that to show the effect. You don't see the effect quite so well over the wire, but that's an example of that. They've done a really nice job of supporting that functionality. So that's the Space War Starter Kit. We also saw the other two starter kits that were just purely C#. This one, again, is an example of a game that will run not only in Windows but also on the Xbox 360 because it does use the XNA framework. So let's go ahead and pop back over. And at this point, we're going to talk about XNA games themselves. I do have a few questions in the queue. Let me see if I can tackle some of those. G's asking, can I integrate workflow for game logic? Actually, I assume WWF, you're talking about Windows Workflow, and that's actually acronym is just WF, by the way. WF for games, you can do it, but then you're going to be limiting yourself to only Windows. And remember that workflow is not a performance system. It's not designed to be fast as in game logic. So you might be incurring a little bit of overhead there. Again, the idea is to keep the game logic as light as possible. And workflow brings too many things to the table that you don't necessarily need. For example, the ability to persist your workflow. That doesn't make sense in a game, so you might not want to consider that. Chaz is asking, I'm guessing this one will not work for Windows Mobile. Now this does not work for Windows Mobile at this point, and that is correct. So how does deployment work? Can you burn the game to a CD and DVD and run it on the Xbox 360? Actually, Michael, on the Xbox 360, I'll be getting into that. We're going to be talking about the Xbox 360 Creators Club. We will be talking about that in just a second, though. And Bruce is asking to see if I could just change the brush to show the demonstration of the effect. And actually, it still won't show up on the display. It just doesn't look good there over the wire. I recommend you download it and play with it. And okay, so let's talk about XNA games. I did point out that they derive from the Microsoft XNA game class. That game class is the basis of it, and it only has two major things. It has the draw method and it has the update method. The update method is the method that basically updates your game logic. The draw method is the method that updates the display. Something I didn't point out, but we will be pointing out in just a second, is that we do have another class in there as part of our game that we call the content manager or the content pipeline. And to load items, for example, images of the spaceship or sounds that we're going to be playing and things like that, we simply load them into a folder, a content folder for our game. And that content folder basically will, contains the audio files, any fonts you're using, any of the models, which are the three-dimensional models of the spaceships or whatever for that, as well as for the things like textures and shaders, which are more advanced game topics that you can apply to your objects while in there. Those are all going to be loaded into that content folder into their appropriate subdirectories. Once they're loaded into that folder, the content manager has access to them, and I can simply tell the content manager to load those images or load those items, and I can then use those items as a standard object. Somebody was just asking about how do I deploy these games. On the Xbox 360, you have to, on Windows, you can deploy them any way, any of the standard ways. So you can build a setup file, an MSI file, put them on a CD and do whatever you want to. There's actually no limit on what you can do with Windows. But because the Xbox 360 is a closed system, it's not really an open system like Windows is. You have to go through specific channels to get the applications running. And today those channels involve the users being a member of the Xbox 360 XNA Creators Club, which is actually a version of Xbox Live it costs $99 a year or $49 for something like 4 months. But what that allows you to do is it allows you to build games and then deploy them to anybody else who is actually a member of the Creators Club. And they would simply connect to Xbox Live, and your machine would connect to Xbox Live, and then you can simply deploy it to their machine. Now, there are new deployment options coming out here shortly that are going to allow you to get to that information in a much those games in a much cleaner way, if you will. But they're still working on that. And let's see here. A couple other things to point out. You can go out to creators.xna.com, and actually I think it's let me get the right link to it, because that appears to not be working now. As I type that in there, that link for whatever reason didn't work there. But the XNA, you can go out to xna.com and actually learn about XNA. And then there is the Creators Club out there. Just going out to xna.com will take you to a link that you can actually type in. And actually, the link is right. XNA, it's creators.xna.com. So that link is right. Out there, you can actually go out there and explore the forums that are out there. Take a look at some of the sample applications that are out there, and we've got quite a bit of documentation out there. So we're getting down to about 25 minutes. Let me go ahead and pop into a nice demo that's going to consume the rest of our time here. And this is actually going to be building an XNA game. We're going to show you how to build it from scratch and show you how to load some content and go on from there. By the way, here is that site I was just talking about, the XNA Creators Club Online. You can see that out there you can go through some getting started. There's some tutorials out there. We have several samples as well as starter kits that are available. One of the new starter kits is the Marblets starter kit, which is a pretty cool game that includes models and textures and sounds, so you can learn how to do all of that. It's a puzzle-style game, and you can go ahead and download that. There's a couple of them, one for Windows and one for the 360. And then it just shows you how to install this. It just installs in the My Template section of your C# Express. Okay, so let's go ahead and create a new game. So I'm just going to do File, New Project. And in this case, I'm going to use, notice that we have Xbox 360 game and we have Windows game. These are the two that are added with XNA. We also have the Windows game library and Xbox 360 game library. These are basically for building assemblies or DLLs to contain information. They do not run on their own. They would be added on, as a part of somebody else's game. So we're just going to create a Windows game here. When I click OK, that's just going to go ahead and create an empty game project. And again, with our empty game project, we inherit from the game class. We have our graphics object that we're going to be dealing with, and we have our content. This is that content pipeline that I'm talking about. And you can see that in the constructor of our game, we actually spin those two objects up. We also have down here a couple methods. One that would be called where we load our graphics content. This isn't necessary to have, but if you're going to be loading items, this is a nice place to call it, so we've automatically included that for you. And naturally, there should be a place to unload that graphics content. And we have a method provided for it already. In some cases, you might want to change the way this works, so we've included that method as well. And then the two important methods that I talked about are the update and the draw method. Here's the update method. This is where we actually update our game logic. And you'll notice that in this one, we've automatically included some functionality to return the state of some buttons from the Xbox 360 controller. So we're just using the gamepad's getState method to get the state of the back button. And we just check to see if the back button is pressed, and if it has been, then we can exit out of it. This is something that's really nice to have, especially if you're building an Xbox 360 game where you don't have a keyboard or a mouse on there where you can shut down the application. And then you simply are going to add any game logic that you might have here. And then to draw on it, to draw the application, you simply add any code that you want to draw your application down here. In this case, it's going to default to a cornflower blue background. Let me just go ahead and run this and show you what this actually gives you. It gives us this beautiful blue rectangle with nothing in it. Not exactly a pretty looking. In fact, if we're building a space war game or space game, we probably want to have a black background. So if I run that again, I can go ahead and display a black background instead. So now I have my space with no stars in it. And you can play around. There's different various ways of getting stars and objects in there. But let's go ahead and start off with making a game that kind of does something for us. And remember, in this project here, I was talking about creating a content folder for adding items to this. Well, to do that, I'm just going to create a new folder. The new folder is going to be called Content. And inside this folder, I want to go ahead and add some items to this. I'm going to create another folder, and we're going to call this Models. And in my models, basically what we're going to have here is our three-dimensional models of our ships. I'm going to create one more folder here called Textures, because a model is going to have textures applied to it. That's going to give us the colors and the up-close look and feel of it. And if I wanted to, I could put in audio in here and sound and things like that. But we're just going to stick with models and textures today to show you how they work with XNA. So to do this, I'm just going to go ahead and steal a model that's been already created for me. And the reason I know it was created for me is because we just created it a second ago when we did the Space War. There's my Space War project. And you'll see inside here we have content. And inside here we have audio files, we have fonts, we have models, shaders, and textures. I'm just going to drill down into the models, and I'm going to change this to my file type to content pipeline files. You can see this is a nice addition here. Allows me just to deal with those types of items. And I can go through here and I can now pick out the type of object that I want to deal with. We were playing around earlier with some of those spaceships. I kind of like the P-2 rocket. The P-2 rocket is one of the spaceships that's included with the Space War starter kit, and we're just going to steal that guy. So we're just going to add the P-2 rocket, and I'm going to go ahead and press the F4 key to bring up the properties of this. Notice that the asset name is called P-2 rocket. I can call this name anything that I want to. This is the name that we're going to use as our friendly name of what our object is. And I'm just going to call this my rocket model. So I now have a spaceship. It's called P2 rocket. And notice that this is a .x file. And .x indicates that this is a DirectX three-dimensional object. To create this, a lot of people are going to ask how we create these. There are various different tools that you use to create it. I happen to use a tool called Animator, which is a free download. Just go out and do a search on it. And it's ANIM8OR, so the number 8, Animator. And then that creates a 3DS file. And then within the DirectX SDK, there's actually a tool included in there that will convert 3DS files into the .x format. And in addition to that, we're going to have some textures that we're going to apply to this rocket, because if I just had this rocket is simply a three-dimensional object. It doesn't have any colors or anything like that applied to it. Those get applied with textures. So I'm just going to go ahead and add all the textures that apply to that P2 item. So here's P2, and we'll just go ahead and grab all the P2 items in there, but there's the P2 rocket texture that we're going to be using. So I've just applied all these P2 textures. These are just items that would be used to add things like here you can see the reflections, the background, the actual surfacing and things like that of this. Those are automatically dropped into it, and once I put those into this folder, they're automatically available to me as a game developer. So for example, if I wanted to load up that rocket, I'm just going to go ahead and create a model here. Let me just go ahead and spin up a new model class here. We'll call this model Spaceship. So there I have my new spaceship. I'm just going to go ahead and load my rocket model as that spaceship. So spaceship is equal to, in this case, we're going to go into our content manager there. And you'll notice that we have this load method. The load method basically is going to load up our model for us. So in this case, I'm using the generic content model. So we're going to go into the content directory. We're going to the model subdirectory, and we're going to pull up that rocket model that we just created. Now you'll notice that these are directories, but the name here happens to be the asset name. It's not the file name that we're dealing with. In fact, it's the asset name that we're dealing with. So I'm bringing up this asset. So what this just did is it loaded that model rocket into the spaceship class, which is actually a model class, as you can see. So I'm calling it spaceship, but it's actually a model that I loaded into this. And now that I have that model, I can start doing things with that model. For example, I can start displaying it. And if you remember, we display things in the method called draw. So what I'm going to do is I'm going to go down to my draw method, and I'm going to go ahead and start adding some code to my draw method that's going to allow me to display that. Now, this is where the the game development gets a little bit harder. When we start dealing with three-dimensional objects and things like that, we need to start thinking about the way items actually work. And in our case, when we're building graphics items, this model is a three-dimensional model, so therefore it has to be represented by some kind of mathematical representation that understands what this, how to hold this. And because we're going to start rotating this thing in three-dimensional space, we have to calculate all those little points and have some kind of a container to handle all those. So what I'm going to do is I'm going to create what we call a matrix. And a matrix is actually an array of items in it that hold those individual points. And we're going to call this my transforms array. So my transforms array is actually going to be create a new matrix. Now what's interesting is I'm going to load my spaceship into this matrix. So I have my spaceship, and I'm actually going to count the number of items that I have in this spaceship. This is the number of elements that are in that. A bone is an individual segment, if you will. So if I have a cube, there are going to be about 12 segments that represent that cube, and those are the individual sides, if you will, or the corners from one corner to another corner. Those can be represented as a bone, and a spaceship contains a whole bunch of those. So what I've done is I've created an array large enough to hold all of the elements in that spaceship. Now that I have those elements, I can go ahead and copy those into it. So I'm going to tell my spaceship to go ahead and copy those into my transforms array. So copying those, basically I'm copying everything from that spaceship into that array now. Now that I have that, I can start dealing with that. And I appear to be missing something here. Let's see what I'm missing here. XNA, Studio, Audio, Content, Graphics, Input, Output. Now that actually looks like it's working. Look here. I need to declare my spaceship. That's what I messed up there. It's not an array. That. I knew something didn't look right. There we go. So now my spaceship looks better. So this should automatically give me an IntelliSense. There we go. Copy transforms to. Okay, now that I have those in my spaceship, I've copied them to that matrix. I can now start playing around with displaying that. And to display that, I can simply go through and loop through all of the items in that model. Now, when we say model, we're talking about this spaceship there. That spaceship actually contains a collection of items inside it called meshes. And a mesh is an individual collection of those bones. So a spaceship might have a laser gun pointing out the front of it. And that laser gun might be independently modeled from the rest of them. So we're going to go ahead and spin through each one of those in that spaceship and display it individually. Now to display that, we actually have to assign some different things to each one of those. So each one of those meshes is going to have some specific attributes that are going to be applied to it. So for example, there might be a lighting effect, or there might be a rotation that we apply to it. So what I'm going to do is I'm going to go through each one of the effects in each one of those meshes, and again apply some items to that. So our spaceship contains 3 windows. Each one of those windows is going to be represented by one of these meshes, and each one of those windows might have a different lighting element applied to it. So the sun might be on one side, and it might have different effects calculated on each one of the 3 different windows. So what we're going to do is apply those effects to that. Now, what I'm going to do is I'm just going to go to the effect and tell it to apply the default lighting. And that's just going to use whatever the lighting effect is on those. And then the next thing that I'm going to do is I'm going to go ahead and set up a viewport. We're going to be looking at this spaceship from some point of view. And this is going to be a little bit more complex than what we're used to, but what I'm doing is I'm creating a look at. This is a viewport that I'm going to be looking at this spaceship from. So we're basically defining what we call a camera position. And our camera position is going to be some location that's out there somewhere. To do that, I'm going to create an object called camera position. Now, it isn't defined yet, but we will get there in just a second. And then we're going to tell it that we have 2 locations, our target and the point of view. Which way is the point of view? And our target is actually going to be at the center of the screen, or the center of the spaceship, if you will. So I'm going to create a vector 3 that's actually pointed at 0, 0, 0, which is the actual location of our spaceship. And then I'm going to set up another vector, which is actually going to point up. And this is going to say, this is basically, where is the top of the camera? It points to the top of the world. Remember, we're going to be placing this object in this virtual world. Now I have this camera position that I haven't defined yet, so let's go ahead and define that camera position. Our camera position is actually going to be another one of those 3-dimensional vectors. So we have this vector 3 called camera position, and it's actually going to exist at some location. And that location is going to be, I'm going to go ahead and define a value that I happen to know is going to be accurate for this. Basically what we've done is I've set up a 3-dimensional vector position that's going to have a 0 offset here, a 5,000 and a 5,000 offset here and here. So think of this as X, Y, and Z, though it's not that simple. Once you start playing around with this the cameras in space and things like that, you'll start to understand that the positioning of these elements is kind of arbitrary to what we think of from the typical graph that we learned in high school of X, Y, Z. There's a lot of reasoning behind that, but just trust me on this positioning here. This is a good position. So we're basically going to create a look at. I'm going to place the position at some location that's 5,000 elements back from the position of the spaceship. And now that I have that, I can go ahead and tell the effect that we're going to have a projection. And the projection is basically a field of view. This is going to be where we are, how big is the field of view that we're looking at. So I'm going to go ahead and create that matrix projection. And we're going to create a perspective field of view in this case. Now I'm going to use a little bit of helper routines here. We have this little thing called the math helper, which is a really nice set of classes that allow us to calculate things like converting from degrees to radians. So I'm going to take 45 degrees, and I'm going to convert that to radians. I'm going to go ahead and set my aspect ratio, and I'm going to define that in just a second. So I have an aspect ratio, 1.0, we'll set that, and we'll set that distance of the far plane. Remember I had 5,000 as my distance. In my camera position is going to be 5,000 away from this. Well, to make this at the center of the screen, I have to have my field of view be 10,000 away from me. And what this is going to do, this is going to take that field of view and put the camera. Basically, I'm going to be half the distance away from the half the distance from my universe. My universe is going to be 10,000 elements wide. My item is going to be in the middle at 0, 0, or at the edge, if you will, 0, 0. My camera position is going to be 5,000 away from that. To define the aspect ratio, I'm just going to go ahead and create another item up here. My aspect ratio, and we're going to change this depending on what our screen looks like. But for us, we're just going to use a standard one. I'm just going to create a floating value. We'll call this aspect ratio. And our aspect ratio is simply going to be 640 pixels divided by 480 pixels. So that's a really simple way of doing that. And now take that off so we have the right word, aspect ratio. Paste that to make sure that so if you wanted to change your aspect ratio of your screen, you would simply change this value here. So now that I have that, I can go through here and let's go ahead and do a couple more things real quick. Let's tell this mesh to go ahead and draw itself. And if I draw that self, that's basically going to have that, draw that item wherever I happen to draw that. So now that we have that, let's go ahead and run this and see if we provided it enough to get it to display. And there you can see I've displayed my spaceship right in the center of the screen. And this is the model that I actually loaded up from the Space Wars game. And that's all there is to actually getting this item to display itself. Now what's interesting is I can actually start changing things. For example, I can change my camera position. So if I change my camera position, let's change this to, or if I in my loop here, my game loop, if I wanted to, I could loop through and change these positions, and that would give the effect that the camera is moving around. But I can actually move this actual spaceship in space as well. And to do that, what I might have is I might have some objects in there that define the x-axis and the y-axis of this, the rotation aspects of it, if you will, for example. So let's do a model rotation x, and we'll set that to 0 floating point value. And we'll do another one, only this one will do y value. And if I wanted to, I could do another one and make that the z value. Because remember, we are dealing with a three-dimensional object here. And with that, we can go ahead and set up some additional items. Let's go ahead and tell our object here that it's going to need to transform itself. So we're going to grab the transforms object here, and we're going to look at the individual mesh that we're dealing with. This is the particular mesh that we're actually dealing with at this particular point, and we're going to tell that guy to go ahead and rotate itself, and rotate it about the, in this case, some x-axis. In addition to that, let's go ahead and move it this way so you can see all of it. Let's do another one. around the y-axis as well as around the z-axis. Now what these are actually doing is actually taking the spaceship and rotating those, or basically using a matrix calculation to rotate around the x-axis by some value. Now that x and y and z-axis have yet to be initialized. Right now they're set to 0. So if I go ahead and run this again, we're going to get the exact same output that we got before. The spaceship hasn't rotated or done anything. But now what I can do is I can start applying some logic to this. If we go up to my game logic, my update game logic, what we can do is go ahead and start applying some things. So let's just go ahead and grab a game state object here. A game state, our controller logic here. Let's go ahead and grab a gamepad state. We'll call this GP. And we're just going to go look at the gamepad. And the gamepad that we're going to be looking at is going to be the player index 1. So we're going to look at player 1's gamepad. And if the player 1's gamepad is actually connected, GP, if it's actually connected, because it might not be connected and you don't want to do this, then we can go ahead and set up some model rotation values and change those to be equal to something that maybe the user might be doing. So let's look at the thumbstick, for example, and we'll just set the X value. Now I'm going to rotate this a much smaller value. I multiplied this by a very small value, so hopefully you guys will get the rotation on the screen here. Let's go ahead and do the Y value as well. So now what I have is a rotation for the X and the Y axis, and if I wanted to, I could change the Z axis as well. But this is basically going to allow me to use the thumbsticks to control the rotation on the X and the Y axis of my spaceship. So let's go ahead and run this again. And now when I have this, if I move the joystick, and I'm moving it very slowly, so you guys can see that value, but you can see it rotating there. And now if I go ahead and rotate it on the y-axis, you can see I get a nice little rotation in this way. And I could continue to do this by adding other features to this game. For example, I could use the trigger button to change the position. The position would be another one of these 3D vectors. Basically what we would do is we would take that and apply another type of transformation to this, and that's what we call a translation, where I'm actually going to move this via translating it. But I'd have to assign some other things in there as well, like speed and things like that. So in this case, you can see that we can break it down into very simple steps. I can create my camera where I want to look at. How much of how wide are my eyes, if you will, my perspective field of view here. When I want to rotate it, how do I rotate it? Well, we've got some nice helpers to do things like that. Drawing items like that. We even support collision detection and things like that. This is a very, very simple example, and if you download my code, you'll see that this is pretty much the sample I've included. I've actually added a few other little features. For example, I believe I have the movement in there as well. And there's a few other things that you can play around with. But this hopefully will get you started on understanding the basics of the game. The real powerful feature is the ability to understand that we have the update as well as the draw method. We update our game logic here, and we draw the items in the items here. And this loop right here will allow you to draw pretty much any of the objects that you want. You can have multiple transformations and just loop through and draw each one of them individually, or you could batch them all in together into a nice little collection and draw them all in one tight loop like this. I'm sure there's a bunch of questions in the queue here, but let's go ahead and summarize here, and I'll get to all the questions that you have while we are doing the survey here. So hopefully this gives you a nice little introduction, a 1-hour introduction on the XNA framework itself, and some of the things that you have to think of when you're doing games. The starter kits are extremely valuable in learning about games and learning about how you would build a game, what kinds of logic that you would use, how tight the logic should be, things like that. And then I gave you a quick little introduction on some of the really, really simple basics of building a game. We took some joystick input from the game states, the gamepad states themselves. We did a little bit of image rotation, transformation, and things like that to rotate the item around there. This is some of the basic things that you would start to do when you start building a game. Now, each individual game is going to have their own logic, so it would be hard for me to define that type of logic, if you will. But there are certain types of games that are going to be very similar to other types of games. For example, if you take the example of Wolfenstein, Castle Wolfenstein, and then if you take the example of some other game like Doom, those have a very similar model there. And in that scenario, you would be using the same type of engine, if you will. And there's going to be companies, and there already are, like TorqueX, that actually make gaming engines that you can just plug right into these. So there's quite a bit of cool things that you can do there. I do want to talk about next week. Next week we're going to be looking at, actually my slide is wrong. This is this week's. Actually, it's just the title that's wrong. This is actually C# and deployment. This should say deployment. Forget what that says right there. This final webcast is next week. We're going to be talking about the different deployment options that we've seen for all the applications that we've dealt with. Basically building MSI files and things like that, and how you actually deploy your applications. I do want to thank you guys all for attending this session, as well as all of these other webcasts. You can always contact me via my blog at blogs.msdn.com/wsteele, and you can always send feedback to my manager, Sam Henry. His email address is samhenry@microsoft.com. He loves to hear your feedback about what's going good, what's going bad, and everything. At this point, I want to go ahead and turn it back over to Michael so he can get you into the survey. And while you guys are in the survey, I'll be answering the rest of the questions that are in the queue.
All right. Well, thank you very much, Bill. Let me move to the survey slide. Well, actually, let me tell you that if you complete the survey, you are automatically entered to win a Microsoft Zune player. Just please take a moment to fill out the survey. It's very useful to the presenter, as well as allows us to improve our live meeting experience. And that should come up here in just a moment. And once it comes up, you can click directly on the screen, and depending on how you registered, click on either registered online or all other registrants, and it should launch the survey for you. And with that, I'm going to hand it back to Bill to answer the questions. And because we're running a little late, perhaps he can answer most of those via text in the questions and answers pane. Is that possible?
Yeah, there's just a couple of them. It'll be real short here.
Okay.
Art's asking if we're not using the gamepad, can we accept input from the keyboard as well? You certainly can. And if you're running on Windows, you can also accept input from the mouse. Xbox 360 supports the keyboard. It does not support the mouse. Matthew's asking, how do we allow the second sample application, Windows Game 1, to run on the 360 without recreating the entire project? Right now, you have to create a separate project template. But then you can simply either copy the files in, or you could just import the same classes. And those are the only two questions I had in the queue.
All right. Well, thank you very much. If you can maybe stick around for a couple of minutes in case some other questions come in, you can answer them via text. Otherwise, I want to just thank you, Bill, for another great presentation in this series. And I want to thank everyone for attending today's event. Ladies and gentlemen, that concludes today's MSDN webcast. You may now disconnect from the audio portion of this conference.